this video, they want us to find the area of the pink shaded region. So as you can see, this outer square or outer figure is a square because this side is 8 and also this side is 8. Therefore, all the sides of the figure are equal, meaning it's a square. Also, we can see that this from here to here is 4 and from here to here is 4, meaning also this here is a square, and inside this small square is inscribed a circle, okay, as you can see. So with that information, what is the area of the shaded region? So let's start by labeling the points on our figure. Let this be A, this B, C, D, this point here E, this one F, G, this H, this point of tangency I, and this point of tangency here J, this point of tangency K, and this point of tangency L, and this point where this line here is tangent to the circle, let it be point M. Now let ED be equal to X. So let this length be X, length X, okay? And let the center of the circle, let it be O. Now next, let us connect center O to point of tangency J and also O to point of tangency I. So connect O to J and O to point of tangency I. As we know, due to tangent to a circle theorem, angle formed by radius and tangent to a circle is 90 degrees. So this is 90, this is 90. Therefore, AJOI is also a square. Now, if we were to complete this line to point K, we would come up with a diagonal IK. And since we know that AFGH is a square, then that implies that HG is equal to IK. So if HG is 4, then IK is also 4. But remember, IK is the diameter and the radius is IO. Therefore, IO will be equal to a half of IK, which is a half of 4. So this will be equal to 2. So IO is equal to 2. So if this is 2, then AJ will also be equal to 2. Now, since ED is X and AJ is 2, then that implies that JE will be equal to AD, which is 8, minus AJ, which is 2, minus ED, which is X. Okay, so JE will be 8 minus 2 is 6. So this 6 minus X. So from here to here is 6 minus X. So this is 6 minus X. This distance here, JE. Okay. Now we know that from two tangent theorem, it states that if two tangent segments are drawn to a circle from the same external point, then the segments are equal. So suppose we have a circle and we have two segments drawn from the same external point to the circle, then this segment is equal to this segment. So going back to our figure, that implies that JE, segment JE is equal to segment ME. Okay, and we have seen that JE is 6 minus X. So this will be also 6 minus X. So ME is 6 minus x. Also, since this is a square, and we saw that the side of this square AJOI is 2, so this side is also 2. Now, since this is 2, and we know that AB is equal to DC, which is 8, so AB is 8, and AI is 2, then IB will be equal to 8 minus 2, which is equal to 6. So from here to here is 6. Now we have seen that from two-tangent theorem, if two tangent segments are drawn from a circle from the same external points, then segments are equal. As you can see, tangent IB and tangent BM are being drawn to the circle from the same point B. Therefore, IB is equal to BM. And we have seen that IB is 6. Therefore, also BM is 6. So from here to here is 6. So therefore, line BE is equal to BM plus ME. And we have seen that BM is 6. And we got ME as 6 minus x. So this gives us 12 minus x. So this whole line BE is 12 minus x. Now focusing on triangle ABE, this one here. So this is our triangle ABE. Now AE is AJ plus JE. But remember, AJ is 2 and JE is 6 minus x. Therefore, we shall have 2 plus 6 minus x, which gives us 8 minus x. Therefore, AE is 8 minus x. Then this side AB is 8. And BE, we've got it to be 6 plus 6 minus x, which is 12 minus x. Now, since it's a right angled triangle, this is 90 degrees, we are going to use Pythagoras theorem to solve. Okay, so we have A squared plus B squared being equal to C squared. Our A is 8 minus x. So 8 minus x squared plus B is 8. So 8 squared is equal to C. 12 minus x. This is squared. But from A minus B squared being equal to A squared minus 2AB plus B squared. Okay, so using this identity, this here will become 64 minus 16x plus x squared. Then 8 squared is 64, so plus 64 is equal to, so when you expand also this in the same form, we shall have 144 minus 24x, then plus x squared. As you can see, we have x squared on the other side and x squared on the other side, so they cancel out. Okay, so we are left with 64 plus. So when we bring everything on one side, we shall have minus 16x. When this crosses, it becomes plus 24x. Then plus 64 plus this 64. Then this, when it crosses, it becomes minus 144. This is equal to 0. Okay, so minus 16x plus 24x gives us positive 8x. 64 plus 64 minus 144 leaves us with minus 16. This is equal to 0. So we take that negative 16 on the other side. We shall have 8x being equal to 16. Divide both sides by 8. And so our value of x is equal to 2. But remember, they want us to find the area of the shaded region. Okay, so area of shaded region, area will be equal to area of the square ABCD, okay, minus area of triangle ABE. Hope we are clear. To find area of the shaded region, we shall find area of the whole square ABCD and then subtract area of the triangle ABE. So first, let's find area of square ABCD. We know that area is side squared, and the side of the square is 8, so 8 squared. So the area of the square is 64 square units. Next, let's find area of triangle ABE. Okay, we know that area of a triangle is given by a half times base times height. So area will be equal to a half. The base of this triangle is 8 minus x. So 8 minus x, and the height is 8. So this 2 goes into 8 4 times. So area is equal to, we remember we got our x as 2, so 8 minus 2 times 4. And so area is 8 minus 2 is 6 times 4, which gives us 24 square units. So remember we said shaded region area is area of square minus area of triangle. So we've got area of square as 64 and area of triangle as 24. Okay, therefore our area of the shaded region is 40 square units. But there is a second method that we could have used to still arrive at the area where at the point where we found x is equal to 2. Okay, so from this point where we got x is equal to 2, we know that EDCB is a trapezium. Okay, and we know that area of a trapezium is given by a half times the short side plus the long side times the height. Okay, so area is equal to a half times the short side is x. Okay, the long side is BC, which is the side, remember this was a square, so DC is equal to BC, this is 8, times the height is also 8. Okay, so area is equal to a half. Remember x is 2, so 2 plus 8 times 8. So area is equal to, this 2 goes into 8 4 times. So 2 plus 8 is 16 times 4. Sorry, 2 plus 8 is 10. So 10 times 4, and this gives us area as 40, just like the previous way. So area is 40 square units. Thank you so much for watching. Kindly subscribe to this channel for more amazing videos. Like, comment, and share your thoughts about the video in the comment section down below. And also, do not forget to share this video with your friends and family for an enlightening experience. See you in the next video. Bye.